right, so we are talking about angles today. So we have a definition here. Angle, two rays in a plane with a common endpoint. The rays are referred to as sides. Let's just go back and make sure that we remember what a ray is. Do you remember from geometry? A ray? It's different than a line. Exactly. So rays have that one endpoint and then one side goes on forever. So most of our angles, there's one ray, and then I would just have another ray that has that same endpoint and it goes on forever in some other direction. So the two rays together form what we refer to as an angle. Okay, now those two sides, we're going to talk about them a little bit differently. One of them will be referred to as the initial side, and the other will be the terminal side. So usually we're going to have our angles so that one of them is horizontal. So you can take a 30-degree angle and you don't have to have either of the sides be horizontal, but you could certainly move it if you wanted to. So the initial side, we really want that to be along the horizontal. So we'll call this guy the initial side. Excuse me. And then this one here would be terminal. Terminal. So let's write in words the definitions for those. So this is the side of angle. By the way, do you know the symbol for angle from geometry? I'm sure. It's just that. It's just a little less than sign. You can put an arc through it if you want to. I usually don't because I'm lazy. So, side of an angle, usually placed horizontally. And then if you think of the two rays both starting in the initial spot, and then I'm going to take one of those rays and I'm going to rotate it. Let me see if I... Yeah, okay. So if you imagine, I have here, this is a really cool kind of fancy protractor. So right now both of my sides are lying along the horizontal, but now I could leave one of those sides. It's not moving very well for me. Leave one of those sides along the horizontal, and then my terminal side, I'm just rotating that one ray to wherever I want to leave it off. I remember this getting stuck last year. I'm gonna have to play with it more. But anyway, so you can see I have my initial side and then my terminal side. Okay, so let's say terminal side. This is the ray's location after rotation. So we have positive angles, of course, and you may not yet have dealt with negative angles. Did you even know they existed? You can have negative angles. So here's how. Positive angles are going to be formed by counterclockwise rotation. Counterclockwise rotation. Okay, so watch this. If I had, there's my initial side. Imagine I had another ray right on top of it. If I took that ray and I rotated it so far that it ended up, say, here, I have now created a negative angle. So hold on, this here would be my negative angle. Oh wait, but I want positive. Oh shoot, sorry. This angle is referred to as the positive angle. Sorry. So my negative angle, I'm going to get that by going clockwise, obviously. Formed by clockwise rotation. Rotation. So if you take a look at my little diagram here, this same angle can be referred to two different ways. I can refer to its positive angle, which is that's a really big angle, right? Or this can just be its negative angle, and they refer to the same thing. So for example, that angle might measure 330 degrees or negative 30 degrees. They're the same thing. So how many degrees in a full circle? 360, right? So if you go all the way around, you just get right back to the full circle. So that's how, if I went 330, well, that's a big portion of the circle, but it's not the whole thing. So if I had gone this way, that's a positive 330 degrees, for example, or I could have just dropped back this way and gone negative 30. Does that kind of make sense? So that angle has two different measurements, a positive measurement of 330 or a negative measurement of negative 30 degrees. Okay? Okay. So degree, we just said that there's 360 degrees in a circle, so each degree represents 1/360th of a rotation. All right, so now let's move on to classification of angles. Do you remember anything about complementary angles? You probably remember complementary and supplementary, and one does something and one does something else. But do you remember which is which?
Complementary is up to 90 degrees, supplementary is 180.
Perfect. Complementary angles have angles whose measures sum to 90 degrees. Supplementary angles have measures that sum to 180. So the best way that I have found to remember which one goes with which, and you can come up with your own if you want, but you have complementary and supplementary. If you put them in alphabetical order and then put 90 and 180 in order, those two go together. They both come first, complementary 90 and then supplementary 180. Okay, so whatever you need to do to remember complementary and 90 go together, supplementary and 180 go together. Okay, so if I gave you an angle of, I don't know, 50 degrees, what would its complement be? 40, because it would have to be what angle would I add to this to get me to 90. So if I'm already at 50, it's got to be 90, right? So take that same 50-degree angle, what is its supplement? 130, right? Because I've got to get to 180. So if I'm already at 50, that would make sense, 130. Okay, does that make sense? Everybody's okay? You remember that from geometry? All right. What you probably didn't talk about in geometry was basically fractions of a degree. We usually rounded everything to the nearest whole degree, or maybe at best, maybe you left it as like 30.7 degrees. But did you know, well, first of all, did you even know that there's fractions of a degree? Well, now you do, right? So think about it. The whole circle, I don't know if you can see it on here very well. Your whole circle is 360 degrees, right? So in this one, you've got 0 here, and you go all the way around, it's 360. Well, if I didn't, this little indicator here doesn't always have to line up perfectly on one of the numbers. So what if it's in between the 10 and the 11? Maybe it's at 0.5, maybe it's a little bit further. So you can measure, just like when we talk about time. We usually talk about time, minutes, seconds, but can't you go smaller than a second? Yeah, whenever you watch the Olympics and they're doing like those races that are really close, they measure it out way further than just to the nearest second. So you can do the same thing with angles. We can measure a lot more specifically than just to the nearest whole angle. So we break them up, oddly enough, with minutes and seconds, but with degrees. So let me explain. All right, so portions of a degree can be written in degrees, minutes, and seconds form. A minute is 1/60th of a degree. And a second is, you guessed it, 1/60th of a minute. Just like it is in time, right? If we think about clocks, 1 second is 1/60th of a minute, right? Right? It's just that once we go past minutes, we're not talking hours now, we're talking degrees. All right, so let's take a look at what we're trying to do in this first example. First, we need to even break down what this is. I know you're familiar with the degree symbol, right? The little tiny circle up there. Yeah. So this thing is 28 degrees, and 35, the 1 slash like that, the 1 apostrophe, that's minutes. So maybe we should jot that down. That's minutes. If I had something that was out even further, like you see in C here, see how there's double? That's seconds. All right, so in this example here, I want to add two angles together that are both expressed in degrees and minutes, okay? So what I'm going to do is I'm going to start off by adding the whole degrees together, and then I'll add the minutes together, but I might have to adjust. So let's start by adding the degrees. So step 1, add degrees. So that's 28 degrees and 63 degrees. That gets me 91 degrees. Now, I'm going to add the minutes together. So in this case, that's 35 minutes and 52 minutes. Oops, silly goose. So 35 and 52, I have that as 87 minutes. But here's the problem. Just like when you're doing hours and minutes, right? If you had 87 minutes, wouldn't you turn that into hours and minutes? Right? So what would 87 minutes be in hours and minutes? Exactly. And it works the same way. If I have over 60 minutes, one of those is going to convert back into a degree. So just like that would represent an hour and 27 minutes, it's going to represent 1 degree and 27 minutes. Okay? So step 3, convert anything over 60 minutes to degrees. So that's now 1 degree, 27 minutes. And now I can finish this out by just adding that 1 degree to the 91 degrees that I already had. So I'll just say finish. So my final answer, 92 degrees, 27 minutes. Does that make sense? It's a little weird, I know. Okay, before we do B, I'm going to give you one to try over here. That's one downside of these notes, is that sometimes there's not enough room to do what you want to do. So if you want to use other paper, whatever you want to do, totally up to you. All right, let's try this one. Try to add together 97 degrees, 45 minutes. Add that to 6 degrees, 50 minutes. Oh, sorry. Okay, did we get somewhere? What do you get when you add the degrees together? 97 and 6 gets you 103. So I know I have 103 whole degrees so far. And now I'll add to that the 45 minutes and the 50 minutes. So that's 95 minutes. But I need to now adjust that. So what's 95 minutes when you convert it? Go ahead.
An hour and 30 minutes. Or so like 1 degree and 30.
Yes, 1 degree, 35 minutes. So now I'll add that to the 103. So hopefully everybody ended up with 104 degrees, 35 minutes. Yeah? Okay. Let's talk subtraction. So if you look at B over here, they want you to do 180 minus 117 degrees, 29 minutes. So here's the problem. This guy doesn't even have any minutes to subtract from. Well, what you can do is I can basically borrow one. So 180 minutes, wouldn't that be the same thing as 179 minutes? I'm sorry, 179 degrees and 60 minutes, right? So then I'll have minutes on either side that I actually can subtract from. So the first thing that I would recommend you do is borrow a degree and make it 179 degrees, 60 minutes. I haven't changed its value, right? It's the same thing like trading in $1 for 4 quarters if I need to, go to the vending machine or something. Now it's in a form that I can use. I still have the same amount, but I'm just expressing it differently. And now I should be able to subtract the 117.29 without too much difficulty. So I'm going to subtract the minutes from each other, and I'll subtract the degrees from each other. Except I totally subtracted wrong. It's okay. It's not like I'm a math teacher or anything. It's totally fine. Oh boy. I tell you. Okay, does that make sense? It was good? Yeah? Okay. So we can add and subtract with our minutes, and then I do the same thing if I had seconds. So we'll practice some in a little bit that have some more. Okay, look at C. C now is asking me, they give me something in degrees, minutes, and seconds, but now they want me to convert this into decimal. Okay, how do you suppose I do that? So I know it's going to be 105 point something, but how would I figure out what decimal this represents? Don't worry, I'll help you. So we have 105 total in all, right? That we have 105 whole degrees. And then I have a little bit more. So what I'm going to do is I'm going to take 105 and I'm going to add to it. Let's talk about this 20 minutes, right? What fraction of a degree is a minute? One 60th, right? We said that right there. A minute is 1/60th of a degree. So if I have 20 minutes, isn't that 20/60ths of a degree? Right? You with me? So I'm going to take 20 divided by 60. So that's how I handled the minutes. Now, the seconds are a little bit weirder. Seconds are one second is 1/60th of a minute. So, what fraction of a degree is a second? Oh, you not 600, but
6,000.
we're getting closer. Basically, I want to know what's 1/60th of 1/60th.
3,600.
Yes, it'd be 1 over 3,600 because you're multiplying those 60s together. So this is actually 32 out of 3,600 of a degree. Does that make sense? It's a little weird, okay? So maybe we should write out some notes for ourselves later. So take the whole degrees. Add the minutes over 60 and add the seconds over 3,600. And now I can just break out a calculator and figure out what this is as a decimal, because I don't know off the top of my head, but my calculator does. So 105, add that to 20/60ths, and then add that to 32 over 3,600. So this thing as a decimal spits out that crazy number, right? And what do they want me to round to? To the nearest thousandth. So 105 tenths, hundredths, thousandths. That's 3 decimal places. So it would be 0.342. And that's all in degrees. Does that make sense? We're all right? Okay, let's try one more just like this before we move on to the next thing. Let's just take, I don't know, how about 43 degrees, 2 minutes, 55 seconds. Turn that into a decimal. Same thing, nearest, round to the nearest thousandths. By the way, if you ever need a calculator, they're over on that cart there. You can always help yourself. If you happen to have your phone, you could use that for now. You can't ever use your phone as a calculator on a quiz or a test, of course. You can. Okay, we got something? Hopefully we did 43 plus 2 over what? 60 and 55 over? Yes, 3,600. Okay. Pop that in a calculator. I know it's going to be 43 point something, but what is the something? Oh, interesting. 43 point. If you're going out 3 decimal places, this crazy number, that's hopefully what you got, you should have rounded it to 43.049. Right? If you're rounding to the nearest thousandths, that's how that one would round off. So, 0.049. And don't forget to put a degree symbol. It is, I know in geometry we get a little lazy with the degrees. We don't always write that symbol. You need it now though, because your answer could be in minutes or seconds or degrees, and if you don't have it designated as which it is, that's going to become a problem. Okay? So do get in the habit of putting it there if we need it. All right? And then I think let's do D, and then I have some for you to try, and we'll break for lunch. Okay? So this is just basically going back the other way. I have it in decimal, but now I want to convert it back to minutes and seconds. So, any thoughts how I might do that? If I gave you like 2.3 hours and I wanted you to convert that into hours and minutes, like in time, what do you do with 0.3 hours to turn it into minutes? Okay, let's go back. 0.5 hours is how many minutes? 30, right? How do you get from 0.5 to 30? What are you doing? You're gonna multiply your decimal by 60. There's 60 minutes in an hour, right? So 0.5, I would do 0.5 times 60, and that's how I end up at 30 minutes. It's kind of the same idea. I need to take this decimal, right? That's the fraction of a degree that I have, and I'm going to multiply it by 60. And that's going to tell me how many minutes I have. Maybe I'll have seconds too. I don't know. We're going to find out. So I know I have 85 whole degrees, right? I have that. Now I have to take the decimal and times it by 60. So we're going to add to that the decimal, 0.263 times 60. So let's see what that even gets us. 0.263 times 60. We get another decimal. So now I have 85 degrees, and the decimal that comes out is 15.78. So that's minutes now. I have 85 whole degrees and then 15.78 minutes, which means I need to figure out what that is in seconds. So what do you think I do with 0.78? So you would be if I was in degrees. But now I'm already in minutes, so I only have to multiply by 60. So we're going to take that, 85 degrees. I know I have 15 whole minutes, and now I need to take the 0.78 and times it by 60, and that'll be how many seconds I get. Now, if this comes out to be a decimal also, which I actually think it does this time, here's where we round it off. We stop after seconds. So I have 85 whole degrees, 15 whole minutes, and then I do have, the decimal that comes out is 46.8. We're going to round seconds to the nearest whole. We're not going to keep going forever, because you could just go down that road, until it comes out to not be a decimal anymore. So the seconds, see here it says round to the nearest second. So that would be 47 seconds. Okay, so there's mine. That is that number. So 85.263 degrees is the same thing as 85 degrees, 15 minutes, 47 seconds. So if you want to write that in words, we're going to take the decimal and multiply by 60. If that has a decimal, multiply that decimal by 60 to get seconds. That right there gets you your minutes. So take the first decimal, times it by 60. You might get lucky and that might just come out as a whole number and then you're done. But so that gets you how many minutes you have. And then if your minutes have decimals, you multiply that decimal by 60 to figure out your seconds. Okay, let me give you one to try. Let's do, I'll stick it over here. Oh, I don't know, how about 14.125 degrees? Change that into degrees, minutes, and seconds.
What did the writing say?
Oh, sorry. Let's see if I can zoom out so you get both. I'll just zoom in for you. If you need the degree, it was 14.125. Did I make it too easy on you? Oh, good, I didn't. Anybody have an answer? Lily, was it? Go ahead. I agree with you. Does everybody get that same thing? So take that 0.125 times 60. The first time you get 7.5. So now you know you have 7 whole minutes. And then just do that 0.5 times another 60 and that gets you your seconds. What do you think? All right-ish? Okay, I think this is a good place to break. So let's stop this.